It's a big room. The last time I was briefing a room this size was years ago in Australia. I was a young Marine major, and I had the job of briefing all the Air Force pilots on the new capabilities of the F-18 at Williamtown, the air base there. About 600 people in there. I was in my late 20s, an egotistical fighter pilot ready to show Australia how great the Marine Corps was. And that morning I went to get dressed in my uniform and there was no belt in my suitcase. So I dread not look down at all at this point lest I lose all my confidence. So I'll keep my, later on I'll tell you how I solved the problem. What you'll hear today is good systems engineers are problem solvers, and so, but we'll leave that for a private discussion. Today, I want to challenge you a little bit. We're not going to really talk technical. We're going to talk about the future as I see it personally, and we're going to talk about the interrelationships between program management and systems engineering. Having been both, actually my real title at the Joint Strike Fighter was lead systems engineer, so anything in the design V was mine. About 600 people worldwide throughout all the international partners that we had. And so doing that and then going to program management, both on the government, US government and industry side, I've got some real views on this, and so we'll talk about it. But first, what I like to do when I talk to a group or they talk to me is I ask them 3 questions. And since this is Thursday, we won't belabor why are you here, or what do you expect to learn, because hopefully you've identified that. But more specifically, at the end of a week like this, I think the 3rd question is germane. How do you intend to change your behavior as a result? Otherwise, this is just a week in Philadelphia, you got good food, you did the Ummer strut. But if you don't take this back and change your behavior, then you've possibly lost some significant opportunities. And so as we talk through this, I'm more used to a give and take, as hard as that might be in a big room. So if you don't like something or have a question, just leap up and we'll work it out. But I would like to have this couch the discussion in terms of this 3rd question. So I told you I have personal opinions. So this is my lens that I'm looking through as my past. Rob did a great job of laying out all the things that I have been exposed to. Space exploration, we figured out an architecture of how to send humans to Mars and bring them back, which is now what's called the Constellation program. I was a commanding officer of a fighter squadron, was also in combat, did flight tests, have that unique experience of having my peers in the squadron in combat come back and wonder what idiot test pilot validated that system. So it's called a feedback loop, I think. And yeah, so worked in and around the shuttle with that team. I have a couple stories, and then my last job in uniform was in the lower right there with the Joint Strike Fighter. Also, that the decal or the emblem at the bottom is NORAD, the Defense of North America and U.S. Space Command. I was the J6, the Communications Operations Chief, making sure that all the communications throughout our component commanders and European allies, especially Canada, were ready in case something came over the poles in terms of strategic warning. Also, part of that job was computer network defense. And so I realized a lot, looking at the roster of attendees, there's a lot of software and IT or information-centric folks here. Defending the Department of Defense computer networks from Space Command was a very daunting task, especially for a guy like me, because at that time, when you mentioned a router, I thought you got to the tools section at Sears and picked it up. So I had a lot to learn, but it taught me something about systems engineering in the information world as well. And the decal at the top is NAVAIR Syscom, Naval Air Systems Command, the procurement authority for the Navy, deputy program manager for the F-18 there for a while. So a wide government and industry experience, but mostly in defense, which is particularly a possible obstacle as we interact, because I just don't have a lot of commercial time. But I think a lot of this transfers, and we get to discuss that. So this is it's an interesting time environment. You talk to academics in international relations, and they'll tell you that future conflict will be between or involve non-nation states over natural resources as we urbanize, flock toward urban areas in Africa and the Middle East. How are they doing? Pretty good, right? Taliban, Al-Qaeda. If you look at Israel-Palestine conflict, it involves mostly water. If you really look at where a lot of the conflict is going on, and you look at what's going on in Africa, it makes some sense. And so the reason that's relevant is that whether you're in defense or in commercial industry, that kind of lays out how volatile the economy could well be. It also, for those that are big in conflicts and war, it goes back to Clausewitz and Sun Tzu talking about the asymmetries of war, and certainly we've seen that in how we've been attacked, be it in Boston or over in Afghanistan. And so it's different than it used to be. For those of us that were kind of nurtured in the 60s and 70s, there was the Soviet Empire. It's just a very, very different time. You look at information. The picture on the right is perfect to me. Everybody is tied in. Everybody is tied in. Information now is validated very, very differently than it used to be. You know, in my view, long gone, or that's too extreme. If you look at what chief engineers have done in the past, where you kind of sit on the mountaintop and wait for people to come to you so you can pass wisdom, information is now being validated through Wikipedia or through some kind of social network where you get 99 responses and 98 of them say the same thing. We tend to validate data that way. Very, very different. And then there, of course, is the budget volatility that is not only within the Department of Defense at the Pentagon, but it's just throughout the world. And so the classic industrial might that Eisenhower talked about, the great defensive industrial giant, is really being tested now. Programs like mine that are in the billions of dollars, we're being told, I don't care what you say or what your problems are, you're going to break the cost curve and you're going to come in at so many % below what you're used to. It is what is being demanded of the market these days. So how does that impact systems engineering, and how does that impact program management and systems engineering? So let me back up. Basic engine model, right? Input, output, the system in the middle. What's missing? The feedback loop. Right? I would offer that in my experience, in both in the government and industry, surprisingly as basic as this is, that is a major risk in most programs is the feedback loop. We tend to say, hey, you know, there's a risk there, let's go to lunch. Right? And you go, oh, hey, look at the time when we're off doing something else. I saw an abstract for the week where we were where the whole point was looking at program management risk versus systems engineering risk. I find that an interesting topic when you're supposed to be talking about total system risks, right? And so when we define a system, we commonly kind of look at something very simple like this, and I don't mean to insult anybody's performance, but when we look at this, in industry at least, we tend to say, all right, this is what we are asked to do, we're going to go do it, we're going to put all these packages together, we put them down, we cost them out, and we send it to the government, in my case, and say, here's your price. What's missing here? Anybody? What's missing? Oh yeah, I mean, certainly you need the feedback loop, right? Right? I call it the environment, right? Do you think you have one input source? Right? Let's, you know, the slide we just talked about. There is so much uncertainty and so much chaos and so much complexity, right? How do you capture that? How do you work within that trade space? Professor Collins, I believe, talked about it on Tuesday, right? And he, you know, in viewing where he is, you know, that there is a very scientific way to go after complexity. I look at it just kind of the basic knuckle-dragging program manager. It's just hard out there, right? Big data is an example. I'll give you our program, which is was beset by some media controversy, been canceled a couple times by the Department of Defense and revived. all that is disruptive to the standard machinery. And so, a quick story, I had the opportunity to be one of the first guys to fly in a fast-moving jet with a helmet-mounted display where all the information is on your helmet, on your visor. And the first thing I asked is, how do you turn it off? Because you can't see. You know, you're like this. So you know how fast you're going when you hit the mountain. And so, data management, right? So how do you do it? And you add to that, any thermo folks in here? Entropy is always increasing with, excuse me, I'm losing the mic. With chaos, chaos increases. So let's talk for a minute what this means to you, us. As a systems engineer, here's a good example of maybe a separation between a systems engineer and a program manager. Let's take a standard risk. Your standard systems risk, probabilistic risk, you got your risk cube, and let's look at an analog mitigation plan where you start at some high level, then something happens and it comes down, and you stair-step down to a tolerable level of risk, right? Every one of those horizontal activities across time is flat. In actuality, what is most likely happening to that risk as you wait for that next event? It rises. To a program manager, you have a tolerable risk ceiling above which you are no longer willing to run the program the way it is. If from a the quote systems engineering standpoint, where we say you're following the process correctly, you need the mitigation steps, you need to have those steps laid out, you need to put them in the integrated master schedule, you need to fund them, and you need to do all this stuff, we're just fine cruising along till that next step. Whereas the program manager, either through the fur in the back of your neck or some other means of metrics, is watching that thing climb. And where I'm going, the whole point of the talk today, is we no longer have that luxury. We can't afford the luxury to be looking in two different directions. From a process piece and how do I integrate things kind of strictly to the process versus the more ethereal, how do I lead folks to finding the solution? I'm speaking a little bit in hyperbole. Certainly I'm speaking in extremes. We're not like that. But there is a tendency to corral or bin us, either as systems engineers or as program managers, in that fashion. And when you look at what's going on in places like Boeing and other big industry where your employee to management ratios are going up to save money, we're all starting to try and emulate how the small business companies work around here, at least in this country, with not so much bureaucracy. We can no longer afford to have pockets that are, in a sense, off in different directions, looking at metrics different ways. And when you look at what systems engineers do, integrating across the system, how is that different from a program manager? In my view, the Venn diagrams overlap very, very significantly. And I think it's time that we realize that that's the case. Organizationally, we're siloed apart. How do we, as a systems engineering function, understand our role as leaders? Not even program managers, as leaders. So let's talk about how you do that. Art Athens, anybody getting the eye chart yet? Work on it. So, Art Athens is a colonel in the Marine Corps. He's in charge of the Department for Ethics and Leadership of the United States Naval Academy. If you read his resume, it's stunning. The guy has been so many cool places worked for and with so many excellent leaders, it's just amazing. And he boils down leadership into three basic tenets or steps, principles, whatever you want to call them. First is to have a vision. Know what you want to do and be able to articulate it. The second one is humility. We'll talk about that. And the third one is constantly be checking on yourself or have somebody checking on you, that feedback loop, right? But back to the vision requires that someone understand what and where they want the team to be. And in my humble opinion, that includes definition of the system itself. And frankly, I think we all have a weakness in identifying the system as the platform with wheels on it or the medical machine that's stuck next to you in the hospital bed, right? And when you think about it, you think all that uncertainty and chaos and complexity, I think we sell ourselves short. So Mary Logan was here earlier in the week and deals in how to integrate amongst medical monitoring equipment. Well, we got into a conversation on Monday, and it didn't last very long before we started talking about the patient. I mean, the patient is kind of important in a medical system. And then also when you start talking about the administrators of that, of the cure, nurses and doctors and everything else, pretty soon your system is defined not only as machinery, but as the user and then the kind of the generator of the machinery or the originator of the machinery through the hospital itself and the hospital staff. And so the vision that we have to create has to very clearly articulate the scope of that system. And in my view, one of the areas we don't talk about very often is about the people. How often do I stand around engineers and say, who are you? And the first thing someone will say is, I'm an electrical engineer. It's an interesting name, right? We classify ourselves by our discipline. I'm an aero engineer, but not really, because that's in the mechanical engineering department, right? I've found that in aviation, you have to know a whole lot more than lift is directly proportional to true airspeed. And so some of the things that Professor Collins had talked to us about was how at the University College in London, you take much broader engineering experience learning to try and get that wider view, and then you throw people somewhere into test or validation to give them even a better look at that while they're getting that very specific, passionate look at whatever they like to do. It's an interesting philosophy, and it's something new and probably something we need to go forward and do. And when you look at what he's talking about, he's talking very much about how you get enough credibility across the expanse to lead across the expanse, which is the same volume that the program manager needs to look at. Am I making any sense in connecting the dots? So let's talk about this, Edsel. For those of you not from the United States, Edsel was an amazing attempt at a new car in 1957. September 3rd of 1957 was E-Day. And put it in perspective, that was 12 years after the end of World War II. So E-Day had kind of real victorious connotations. Within 2 years, 3 years precisely, the car was off the market. They advertised the car as being this new breakthrough, revolutionary, never seen it before, but actually it had a Ford chassis on it. It had a lot of the same stuff that Ford had. Nobody went out and tested the market with the customer. One reviewer I read about said that the front end of the car that has what they called the horse collar view in the middle looks more like an Oldsmobile sucking on a lemon. In today's dollars, it costs Ford Company $4 billion putting that out. Now, there are all kinds of blames to be laid. There was politics involved. Robert McNamara, future Secretary of Defense, was in that program or was involved in it. It could have been the politics. It could have been the fact that the customers didn't like it. There were real reliability problems. By the way, they laid the plants out. They didn't have a dedicated plant for the Edsel. They just kind of threw it in the middle of other makes at the time. So the guys on the floor had to stop doing 6 of these and go do 1 of those. And they had real problems with it. From a systems engineering standpoint, to me, they didn't define the system very well. They defined the system as this. And they didn't define it the same way that the marketers did or the chairman did. And pretty soon you had different definitions of systems all the way across the board. And the vision, which is create a 4th division of the Ford Motor Company behind Ford, Lincoln, Continental, and then this, right, never got down to the design process or the marketing process, really. Separate systems engineering and program management in a way. The iPad created a market. It has to be a pretty cool vision there, right? I mean, we didn't even know we wanted that thing till they made it. Boeing shot in the upper right, that's a 787 in the background. The vision for the 787 is turn every airport into an international airport. It's pretty compelling. So you have to make it so that it can go very, very far distances and not need much runway. So they made it out of composites. They're using fuel-efficient engines. The marketing, that's the other side of Boeing. I don't see it very much, but the marketing is right in line with that. With a couple stumbles of the new aircraft, it seems to be working. We'll see. The market catches on. Interesting vision, though. Lower right is Project Frog. Anybody heard of Project Frog? Cisco. I'll get close to the mic here. It's out of San Francisco. It's a team of about 40 people. The CEO is also the lead systems engineer, who is a former marketer from BP Oil. And what Project Frog is to take a Lego block of building structures. It's not prefabbed housing from the 50s from the Sears catalog, right? It's a way that you can modularize pieces of the building and put them together through a standard process. They have everything from state welcome centers on the highways to schools, and they put these things up in 6 weeks rather than 6 months. Not a lot of bureaucracy. No desks, no offices, just a big room. And much of the room is dedicated for everybody's bicycles. That's how they get to work. So those of us from Boeing were looking at it going, now this is an interesting way to do business. Wired Magazine, Chris Anderson, the chief editor-in-chief of Wired Magazine, talked to us one day. That's a great story. He's out with his kids. He wants his kids to be techies like he is. So he buys a Mind Blaster, Lego Mind Blaster, that's got an Mindstorm, thank you. I'll get in trouble in the recording for that, I'm sure. So it's got an autopilot in it, right? His kids had no interest. So he bought him a radio-controlled airplane. They flew it into a tree and went off. So he went running because he's angry, and so he's running around and he's just getting over this, and he goes, I've got this airplane, and then I got this autopilot. So he goes back, takes the kids to the kitchen table, and because he's who he is, they take the autopilot out of the one object and put it into the airplane. And he hacks into the software and puts walls and a floor and a ceiling, builds a box inside the software, launches the airplane, it flies around inside the box, doesn't hit the tree. He then takes the software and puts it on his website, and he now has 250,000 subscribers doing beta testing. They elevate this software and he sends them the hardware for a price, sells them the atoms, and gives away the electrons. He now has an autopilot that's almost at the chip level that's less than $100. So he puts that in one of those little helicopter things you buy at the mall, puts a cell phone camera on it, and he's now got a drone that's less than $100. And he looks at us and he goes, I'm your competition. Different times, but it's based on a vision. And if you look historically at who wins and who loses, it's all about the vision. And I would offer that as a systems engineer responsible for the overall operations of a system, you need a vision. You definitely need a definition of the system. I would offer you need a vision, and it needs to be aligned with program management. And oftentimes, you might have a better collective, semi-tactical, if not strategic view than possibly the program manager as to where that system needs to go. Certainly, the loftier vision, a Steve Jobs or a Henry Ford or some of those visions are critical, but there is a requirement for the matching of visions within systems engineering and program management. There's no doubt in my mind. Space shuttle. What was NASA's vision in the 80s? It still is. Launch humans safely into space and return them to Earth safely. 1986, Challenger accident, what happened? So you can say that, I hear this a lot. We've done a lot of postmortems. I knew a couple of people on the shuttle that crashed, and we talk about losing the vision. They lost the vision and they said they had to launch. Okay, you could look at it another way. Did they include in the air system all the political pressure and the media pressure that they had to deal with when they put the system together? And would they have tolerated O-rings that leak in cold weather if they knew that was the case? Now, it's easy to say that, 20, 30 years later, but think about it. It's a pretty good example. We tend to say, oh, well, they just lost their way. Maybe. Or I mean, when was the last time NASA wasn't in the limelight? I mean, name a launch into space that when the rocket blows up, it doesn't make the front page. So it's an interesting think piece as to how wide a system or how wide a swath you cut when you define the system when you're looking at something like this. And our tendency is to go technical. It's the rocket. This is a huge, huge engineering feat. For you aerodynamicists, those wings, when you go up on launch, your loads on those wings are phenomenally volatile because your angle of attack just races all over the place. So you've got to have the structural strength to deal with that, and you have to have the strength in the flight controls to cope with all that changing of lateral and inertial forces. And your only flight controls are those main engines that are at the base of the shuttle itself. Those solid rocket boosters, they're just going that way, right? And so the phenomenal integration between the engine flight controls and the aerodynamicists. If you ever watch a launch off the pad, the main engines, again underneath the shuttle, ignite, and 6 seconds later, the solids go off. Anybody know why that is? If you look, the main engines are off center. And so when they kick in, the shuttle rocks. 6 seconds later, it's at top dead center, and the solids go off. All very predictable. All cool technical systems engineering. I would offer that systems engineers need to worry about the media. So, it's great to talk vision, it's great to talk strategy, and some of the biggest problems we have as program managers is you go, so okay, I got a great vision, my strategy is magnificent, and then your team goes, so what do you really want us to do? Right, and so strategy to task is a huge problem. It's a huge problem in the military, charging that, the hill or doing whatever. I see it as a problem in industry because if you're a pretty good strategist, sometimes you're not the best tactician and vice versa. And translating a lofty, I want peace on earth to something actionable is very hard. So I thought I'd give you a story about what we did in V-22. What we did is we applied systems engineering methods at the program level. So we had negotiated a specific price, Bell and Boeing, it's a joint program with the government. And we allocated those costs down to specific areas to include part of the organizational and work breakdown structure of the system itself, of the airplane, the platform. And so what you see in the front slide there is an allocation just for our operations guys, the production guys on the floor, and we said, per airplane, you, the quality guy, are going to get me 182 hours. You over here, through learning from your touch labor guys, I'm sorry, to your view like this, each year it's cheaper to make airplanes because you know how to do it each year better. And so through that learning, you're going to get 382 hours, and we allocate all those hours all the way across the team so that every manager now knows what their specific responsibility is to the bigger picture. And so if you look at the back slide, what that is we call it a clamshell chart, is that if you look off to the left where it starts, what it says is our operating cost, cost per flight hour, if you will, hugely expensive to operate the airplane, and the readiness was very low. On any given day, only half the airplanes were ready to fly. And in a span of 5 years, we've gotten the readiness up to 70%, and our cost per flight hour is down about 30 or 40% because of the systems engineering style allocations taking at a program management level. You call them requirements, okay, we did doors, and we did rational rows, and we just laid it all out, and pretty soon when somebody came to work, they knew their relevance was X. And then they were responsible to come back to us and say, this is how I'm getting my 100 hours out of the airplane, out of the cost of the airplane. It's working quite well, actually. But you could start listing all the things that we did at the program management level, and it sounds an awful lot like systems engineering processes and best practices. And in my opinion, it should be driven by the systems engineers, because the system is the cost of the system, cost of operating the system, its readiness, everything else. Can no longer afford to work separately. So, how do you control all that? Well, you need some rules. And so on the left side is I paraphrase, this came from the Toyota Way, which is a book about when Toyota kind of was preeminent in lean manufacturing and very, very low variations for those that are into Deming and those kinds of things. And the big symbol for that Toyota way was people. The people that are, in this case, building the car, right, within an environment of always being focused on the customer, strict process adherence, and then significant problem solving. And what's interesting about that is that if you look at the process orientation and the problem solving, is, you know, you could think or infer that a very stiff process stifles creativity. And so how do you find a way to be able to say, here's the process, but I want you to be a problem solver. I want to give you some leash and some rope so that you can go off and figure out how to do this differently. It's an interesting dilemma. And it's not an either or, you got to do both, right? And never lose sight of the customer. So what we did in order to kind of meld this whole integration scheme together within the team was we took that focus that Toyota talked about in best practices for the production of automobiles, and we drove it to some of the maxims that we have at Boeing that are very similar across industry as to how you do program management. And one of our best practices, if you will, is that every list has an order. I call it a stubby pencil just because of the way it's laid out, however you want to say it, but it starts with safety, then quality, then cycle time, then schedule, then inventory, and finally cost. If you do it out of order, you're wasting time. You can have you can have just-in-time inventory, and if the quality's bad, the part you just got is unusable. And you can work on cost all you want, but if you don't put those things up front, you're stuck in the mud. And so what we do very strictly is we look from a process standpoint is, have you addressed the safety issues? Have you addressed the quality issues? And we just go right down the list to maximize the efficiency. This is something our systems engineers get too. They drive this. This is part of their lexicon. And so in my view, certainly coming from the Joint Strike Fighter program on the government side, if as the lead systems engineer, if you haven't aggravated every member of the design team, you're not doing your job. I'm getting a nod and an amen in here, right? Yeah, that's one of the best metrics on the planet, right? Because that feedback loop is disruptive. It slows you down, it adds cost, it hurts your ego. I designed that, what are you telling me? It has to be, you know, changed, right? So these are things we put in place to put teeth behind some of our processes. I'm sure you have some that you like. And if they're not up at the program management level, there's an opportunity. Go there. So now let me talk about the people. I guess I could go back. It's the one underlined item here is people, right? We talk about risk process, requirements process, configuration management, data management. You know, I'm an electrical engineer. I'm not Bob, right? But when you talk about the team, especially if you're that system engineer who's aggravating the design team, how do you get the team to work together? And so we borrowed this from Joe Owen to lead, and now I'm just talking straight leadership. To lead, you've got to know your people. It's intimacy, and you got to be credible. If you're the chief engineer, you got to know what makes an airplane go. I got thrust into the chief engineer job in the V-22. I got 4,000 hours in jets where anything that rotates is inside a very thick titanium cylinder. And now we got rotors and everything else. And so we had a design review. This is great. The swash plate actuators, to get technical, are owned by Boeing. The swash plate was owned by Bell. We had an issue where the two joined up where we were getting failures and abrasions and all kinds of other stuff. And of course, there's all this going on between the companies and everything else. So as the chief engineer, it was my job to fix it. Oh, by the way, as all that was going on, we were impacting the drive tube, for those that know helicopters or rotary wing aircraft, and that's bad. And so we spent the whole day in this design review with the government in the room, you know, and I'm using my best leadership tactics to get everybody to sing Kumbaya. I mean, in about 5 o'clock that night, everybody's singing the song together and shaking hands and, you know, throwing olive branches, and the government is signing off on it. And I look at a guy next to me and I go, "What's a drive tube?" You think I'm losing any credibility as a chief engineer? So there's one lesson there, is that regardless of what you're talking about, people are people and you can get them to work together despite what they're talking about. On the other hand, it would help to know what they're talking about. So I was better placed as a program manager in a rotary wing environment than a chief engineer. And your credibility as a systems engineer or as a program manager, I would offer is, you got to know how to talk to a stressed guy. I get that. But there's a leadership aspect here that when you say, look, I'm going to sub-optimize your system and sub-optimize your system because my system needs to be optimized, you've got to have the credibility and the trust for somebody to follow you. And so trust is that intimacy plus credibility divided by risk. And this is not the risk cube. This is the risk to the individual. If I follow you, will I lose my job? Right? If I speak out, will you think less of me and I don't get a raise? That kind of risk. What risk do I have in following where you want to go? And so your vision that is highly articulatable, that defines a very good system, has to be dovetailed with the intimacy and the credibility of knowing your team and them knowing you, and then how much risk they see in going there. This is not rocket science, right? But we don't discuss it much. And I think it is critical to the success of a system, of accomplishing a system. Back to the box, input, output, feedback. So let me go extreme. Let me talk about the Marine Corps. In the United States, we have 4 big services. The Army talks about the number of divisions. The Air Force talks about the number of aircraft. The Navy talks about the number of ships. And the Marine Corps talks about the number of Marines. 186,000 Marines. Now, we have tanks, jets. We got all kinds of cool equipment. But it's all about the people. And part of the ethos, the vision of the Marine Corps to be an elite fighting force that is very responsive, that you've got to really kind of apply and be picked rather than just join. It's all part of that larger scheme, right, that the people are all important. So when you're fighting in the middle of some big environment that is hugely uncomfortable and even deadly, you're fighting for the person next to you, which is probably the biggest when you talk to any of those guys that have been in that kind of situation, that's the biggest motivator on the planet. That's how the Marine Corps does it. And it's interesting, I only bring it up as it's an extreme case where we, as a Marine, we never talked about the equipment. Never. The system never included hardware. Now, included, make sure that a howitzer round hits right there. But we always looked at the guy operating the howitzer and didn't tell him, well, that would be 2 cranks on that wheel. We'd just say, apply that, please. Extreme case, an extreme case. And for those that think you can't have a vision unless you're an old white guy that's in a vice president's clothes, right? Mike Strank, Sergeant Mike Strank, 25 years old from Johnstown, Pennsylvania. He was one of the flag raisers at Iwo Jima. That's what that statue is about for those not from this country. Big battle for Iwo Jima. The colonel, his vision was, now that we've taken Mount Suribachi, which is a major part of the island, I want a flag on that mountaintop that everybody on the island and out in the fleet can see. And these guys, comm squadron, they were laying communications wire. Mike Strank was their squad leader. They went up and they hoisted the flag. Joe Rosenthal from, I believe it was one of the periodicals in New York, I can't remember, shoots the picture, becomes famous. Life magazine, was it? Just one of those freak things. He didn't even have the camera to his eye, he just took the picture, and it's become the icon for the Marine Corps and for World War II and everything else. And the reason I put Mike Strank up there is that you can, in his environment, he was a program manager and a systems engineer at 25 years old. His use of his people, his 10 guys as what was called a squad, they call it fire team squad, interacting with organic arms and everything else, as this all had to work perfectly for them to do what they were doing. Ironically, many of them were killed due to friendly fire when a naval gunfire shell landed on them because of inadequate coordination within that system. It's a very extreme case. And so I put it up here for a couple reasons, maybe to wake some people up. You go home and, what'd you learn at INCOSE? Well, we talked about the Marine Corps, But it's an interesting example. You can kind of make relevance out of just about anything you look at. And I offer this just to stretch the thinking, right? That at no time were we really talking about a Jeep, a tank, a truck, or anything else. Instrumental to the system. And in the training and in the operations that a young 25-year-old guy that was actually born in Slovakia would put to his use to be victorious in such an environment is very, very noteworthy. You look at guys who are platoon tank commanders now, they're 21-year-old kids that have this all figured out and are leading, right? They have a vision at their level, like you have a vision at yours. So, what's your vision? You need one, right? Where and what? I should have put in instead of or. Because what is your folks, your culture, your team? What's your culture? What do you want to be known as, your team? Where do you want them to go? And then you can get to how do you get there? You know, we get in that strategy to task to action and all that other stuff, right? But how do you craft the message? How do you be credible? How do you create that intimacy with them? How do you minimize risk? Right? Until you do all that, all these other things just are mechanics. This sets the foundation and the culture for a risk process, configuration management process, a data management process, managing big data. All that stuff falls into place if you have the right culture. And I would offer that as we go forward as systems engineered, maybe the word culture should be more in our lexicon, in our conversation. So, we've talked about this a number of times. I throw this up here just to kind of, it's actually my get off the stage chart, but what it is to say that when you look at your great leadership, define it, I put two guys up there, again, all white guys, but there are numerous examples, male, female, all races, all nationalities, of people who had a tremendous vision, and it worked. And when you look at the common denominators, they all had that vision, they all articulated it well, right? They were humble, they were consistent, they modeled their vision, right? And they were accountable. Now you can read a bunch of books on leadership and that's what you get. I'm being a little bit trivial, but it's true. And so when you look at all that stuff, you've got to figure, well, how do you do that? And so, you know, how many of you are under the EVM system with the U.S. Department of Defense, right? Yeah, raise them high, be courageous, right? You got to have work packages, by God, and planning packages, and you got to take performance and everything else. When is the last time you planned a work package or a planning package on how you're going to lead your team, or how you're going to be successful as a systems engineer? I found in my experience that, you know, if you get in at 7 in the morning, and by 7:15 you're on the email and you're going, you know, writing those emails that you end up putting in the draft folder first because you're so angry at the email. You're not leading, you're reacting, right? And now you're angry, and the first one walks in and you go, what do you want? That's pretty good culture, right? You know, talk about risk, right? And so I had bosses and mentors that said, if you bother me before 7:30 in the morning, there better have been a death in the family or something. That was the time they chose where they were just getting their head right to figure out what they were going to do that day. How were they going to change behavior that day? What were they going to do for the culture? They let the teams do the tactics. They set the culture. And as a leader, as a systems engineer, in my view, you are obligated to be a leader. You put yourself in a position where you have that wider view, that understanding of the definition of the system, the ability to create a vision, and you are obligated to create a culture to make that system succeed. And as an afterthought, I would talk to you about organization. My experience, organizations create silos. I don't care how you put them together. And so one of the first things you might look at when you're creating the culture is how to overcome the boundaries of your organization. So one thing I do is I say there's no such thing as a swim lane. So my public affairs my public affairs guy will speak up during an engineering review. You know, everybody kind of goes, and you are who? I'm getting them involved. Just like the chief engineer says, I don't know that that's a very good message to put out to the media. I'm trying to create systems engineers. Get out of your lane. That's my tactic. You might try something. But it all goes back to all these tenets of where you think you need to be. So that would be my charter as you're heading home today. Some of you greater distances than others. Think about it. Think about how your behavior will change as a result. So this is my first exposure to INCOSE despite all the systems engineering time I've had. I've been very impressed. Was at the Executive Summit on Monday. I've been reading a lot of the abstracts. Kind of wish I could be here all week. I was out doing unimportant but urgent stuff on the program. And I'm actually still intimidated by this crowd. Very humbled to be here and very thankful because your most precious resource is your time. And you just gave me almost an hour. So I thank you for that. And have a very safe trip home. Thank you very much.
Questions?
Yeah, if you got time, I went late.
How that happens, cost to send you 18 pounds.
That's right, yeah, right.
We have time for a few questions, and those questions we don't get to if you have them. John has agreed to stick around after the symposium, go over to the reception. Any questions?
Be courageous. There you go.
Sir, thank you for an excellent presentation.
Thank you.
In your experience, you've had a lot of government contractor boundaries to deal with. Your remarks, could you put your remarks in that context for us, please?
Is the camera on? In actuality, I think there's, in normal circumstances, they're okay. I think they're based on some really good practices, and frankly, a lot of them are based on some abuses of the system that we all have to live with. My concern, which is why I was joking about the camera, is that we're in an environment now with significant cost and economic pressures, and so now what we're getting is these opinions that are kind of a real reach from the federal regulations. And so that tends to stifle creativity and innovation because of the risk that we perceive with that customer base. And so I'm a taxpayer. I like the idea of breaking the cost curve. You know, an airplane shouldn't cost millions and millions of dollars. You know, a toilet seat shouldn't cost $600. So I'm into that. What I'm concerned about is the volatility of the perceived requirements, or let's call them derived requirements that we are getting from the customer base now. I think it's very unsettling. It could be unsettling to the industry, and it actually does drive up costs because we're constantly trying to infer the real requirement as to what they want us to do. Am I answering your question? I mean, this could take 3 hours. I mean, there's real specifics. I think depending on the customer too, it's their culture that you have to talk about too, right? NASA is an interesting customer because recently their directors have said, I want preeminence back in my engineering staff on the government side. So there's a lot more close control and supervision of our engineering on industry because they're trying to regain their preeminence, right? And it would be very, very different. My view of the Army, watching the Chinook and Apache programs that are kind of next door to me, the Army is a very different customer than the Navy. In the end, I think the only way you get a system to work, back to my point, is that you have to work together as a team. And frankly, what concerns me the most is this ethic in the government that you can't team with industry because you can't trust them. That to me is wrong-minded. I think I get the relationship, but the more closely we work together, the less chaos there is and the better chance of success. Fair?
One quick one. Yes, sir.
You had spoke of the Constellation project and the importance of vision. And my question to you was, with the Constellation project, I've looked into it for a little bit, and I've seen that a lot of what you guys are doing is reusing a lot of the old Saturn V program from the Apollo missions. Where's the vision in incorporating new ideas, such as a young entrepreneur not long ago came out with the Spaceship One.
Right.
And he used instead of going straight up and down with a rocket, he took an airplane and then dropped it out of the airplane.
With the shuttlecock reentry, right? Yeah, a very good question. Brief history on Constellation is that back in '04, what they did is they got 10 of the big, oh no, that's not fair, 6 of the big players, you know, Lockheed, Boeing, Northrop, involved, and then they got 4 of the lunatic fringe, as we call them, involved, and now all those guys have taken our business, like Elon Musk and Burt Rutan, for being creative. So, you know, the United Launch Alliance recently disbanded between Lockheed and Boeing, and the main reason for it is that the NASA was contracting with Elon Musk and other folks to do what we thought we were preeminent in. So there's some innovation that's being rewarded there. Specifically to your question, at least when I was there, which was from '04 to '06 roughly, is when the 10 of us that they got together, they said, how would we get to Mars? So one of the things we came up with is that you've got to stop at the moon, because getting to Mars through this atmosphere and this gravity is preventative. The cost per pound to get out of here is crazy. So if you can colonize the moon, there's water ice there, which gives you fuel, hydrogen and oxygen, right? And there's no atmosphere, and gravity is 1/6 of what it can be. There's a company in Delaware that, I'm exaggerating only a little bit, that you take one of their suitcases and hit a red button, and it inflates to a geodesic dome like 28 feet in diameter, and the gamma rays of space harden the structure. So imagine doing that on the moon with no, you know, you can just kind of let it go. So we put all that together, right? We also had winged body aircraft getting up to the moon. But what's interesting is, back to the vision of launching people safely into space and bringing them home, is you now had a requirement, for instance, for re-entry, that in case of a power failure, what happens? Guess what? The way to re-enter the aircraft at about 8 degrees angle of attack with the speed you're talking about, you draw that out and it looks like an Apollo capsule. I got to look at some of the blueprints and some of the basic drawings and layouts of the early Apollo program, both through North American and Grumman. North American had the shuttle, I'm sorry, I've got the wrong company. Anyway, I looked at too many books. Apollo program, and then the lunar lander that Grumman had up in New York. And you look at those blueprints and you look at those calculations that were all done on slide rules. We did the same kind of requirements thing with doors, rational rows. We used CATIA version 4 and 5, and we came up with almost exactly the same answer, which tells you, in my view, how innovative those guys were back then. Now, if they remove that power out requirement, then there might be room for a winged vehicle. Or maybe there's some more, a better way through nanotechnology or something else to achieve that right attitude to get in through the atmosphere as we land. That's just one example. Gamma ray protection, you know, or radiation protection on the way out and back is another thing. When you put all those together, we keep going back to the sweet spot, which is what you've seen already. So even though it appears like no one was creative, we actually went out and came back. Where I see the real, real innovation right now is in stuff you're seeing from what we used to call those other guys, which is just really very different thinking. Not necessarily, they can't necessarily get to orbit speeds now, but they will one day, and we get to figure it out. Like launching from a aircraft, airborne, stuff like that. How'd I do? All right? Answer your question?
Thank you very much, D.D.
Sure.